It's really an honor. I'm very happy that we were able to host this webinar, and thank you for the collaboration with Prilenia for making themselves available. I know they're really busy with everything that happens now with this trial. But before we start, there's one thing I really would like to say, and I don't know who is on the call, if there are any of the trial participants here, but I really want to convey that message on behalf of the entire community. Thank you. Thank you for being in this trial. Thank you for dedicating your time and effort to provide these results. It's so important. We rely on you, and we hope you are taken good care of and that you are hanging in there, because we still need you. So with no further ado, I will just also let you know that you can put questions or comments in the chat. And my dear colleague and friend, Filipa Julio, will help me moderate and pick up from the chat. We will be many people on the call, so we need to moderate and make sure that we keep things in line, I think. So then I will just hand over to Michael Hayden, founder and what is it called? Really been working in this project with Prilenia and with the Pridopidine for many, many years, Michael. So, but please tell us a little bit more about your background.
Well, thank you, Astrid. And let me also first start off by thanking so many of my colleagues, the investigators from all over the world, the patients, the subjects who've been part of this study. We are inexorably linked to the families and the communities, and we share the same goals, which is trying to find something that can have impact on patients' lives. And that hope that we have lives and beats in all of us. So today, I'm going to share together with my colleagues some of the data from the proof study. It's important to note that this is very early. Only some endpoints have been analyzed and not completely. Not all the data or endpoints are yet available. But we believe it's important to share as soon as possible with the community what we know. And we will continue to share with the community as we learn more. And this is very much a work in progress. So I'm going to share some slides. Today, I'm going to share with you some aspects of the results from the proof study. Proof, of course, defining being Pridopidine's outcome on function in HD. And that's really what we're going to be talking about today. On the call today is are some of my colleagues here. You can see some of them. The two PIs in the study are Andrew Feigin in North America and Ralf Reilman in Europe. And also as part of this call, we're delighted that the co-PIs in Europe, Dr. Anne Rosser, and the co-PI from North America, Sandra Kostick, are also with us to participate in this particular discussion. So let me proceed. Today, we're going to talk about the drug itself, Pridopidine, how it works. I'll do some of that. Then Ralf and Andy will give some of the data on the proof, the preliminary overview of safety and efficacy. I'll provide a summary, and then we look forward to questions and answers. And we hope to have this done in about half an hour, so at least half an hour for questions in an effort to try and answer as many questions as possible. So let me tell you about Pridopidine. Pridopidine is an investigational drug. It's in clinical trials for HD and ALS. Today, we won't talk about ALS, but those trials in ALS have been very promising. And there are plans for a phase 3 trial in ALS together with Mass General Hospital and Harvard Medical School, where the initial studies have continued. In addition, this is a drug that has, important to note, it has a side effect profile very similar to placebo. It's safe and tolerable, and that's very important for a drug that may be taken long-term. It's taken orally, once in the morning and once in the evening. And we've shown in the past, and others have shown, that this may show maintenance of function, motor function, and cognition, all very important features of this disease. The mechanism it binds the sigma-1 receptor, which has numerous downstream pathways, including dopaminergic pathways, dopamine. And we have seen in open label, with all the caveats of open label, that some of the delay in progression may be endured up to 5 years, but that was an open label study with all the caveats of open label. Now, how it works and how it protects neurons, it's highly expressed in those regions of the brain that are involved in Huntington disease. These include the basal ganglia. The sigma-1 receptor is expressed in the basal ganglion cortex. It's a crucial door, it's a crucial hub for regulating pathways impaired in Huntington disease, including dopamine pathways. And we do know that the loss of sigma-1 is associated with increased toxicity, including increased aggregates as one biomarker or one marker of toxicity. And when you activate the sigma-1 with pridopidine, it has profound effects on decreasing cellular stress, decreasing inflammation. It improves the connectivity in the brain. It enhances the clearance of toxic proteins, improves the function of the mitochondria, and starts helping to secrete protective factors that provide neuroprotection. All of these are mediated through downstream pathways once the door has been opened through the sigma-1 receptor. So when you look at it, another way of looking at it, it has big impact on mitochondrial function, and mitochondria are the respiration center for the cell. It improves the contact between the mitochondria and other organelles that are very important for function. This is called the endoplasmic reticulum. It restores calcium homeostasis. It enhances the removal of toxic proteins. It increases the secretion of BDNF, which is like a super vitamin for the brain. It helps, improves the connectivity, and has major effect on synaptic function, improving synapses. A lot of these features are downstream through many pathways, including dopamine pathways, which have also some of these effects.
Hi, everyone. This is Ralf Reilman. I'm a neurologist from the George Huntington Institute in Münster in Germany. I think many of you here know me and also know Andy, my co-PI from this study, as a chair of the Huntington Study Group. So we too had the honor to lead this trial, Proof HD. And I would also, first of all, say thank you to everyone here, particularly obviously to the clinical trial participants and all the families for the amazing support this clinical trial has received. I would like to remind us all that Proof HD was, as you can see here, a huge clinical trial. It's a big clinical trial in Huntington's disease. The aim was to recruit 240 people on drug and 240 people on placebo, a total of 480 people. And that was during times, we've all forgotten it nearly, I hope, of COVID. And I can tell you that we were a bit nervous in the beginning, whether this would work in the dynamics that we were planning to see it happen. And you guys made it happen together with all the clinical trial sites. I think it was amazing to see that in COVID times, this study actually recruited ahead of schedule, and we actually over-recruited, so nearly 500 people. As you can see here, again, big clinical trial, randomized, you know we need that. We need a blinded comparison for treatment effects, and you will learn later on how important that is. And we actually, due to the COVID pandemic, we even did some phone assessments here because we didn't really know whether people would be able to come to the clinical trial sites during the pre-specified visit times. You all know that how this works in a clinical trial. You have to do a screening visit to see if you're eligible, and then you get the drug eventually. If you are, you're randomized to either the drug or to the placebo, and then you have to come at multiple instances. The trial here was, the main clinical endpoint is going to be after 1 year and 3 months, but we even extended a little bit to that. So we did multiple sites across the globe. You can see here what countries in Europe participated in the trial and all the sites. There were about 29, nearly 30 sites in Europe. And next slide shows you the participating sites in North America and Canada. So a global trial with 60 centers. Again, thank you all for making the contribution to this trial.
Thank you, Ralph. I'll jump in and talk about who was in the trial in a moment, but I also just want to briefly introduce myself, Andy Feigin. I'm a movement disorder neurologist at NYU in New York City and a past chair of the Huntington Study Group. And I also just want to add my really profound gratitude to the patients and families who participated in the PROOF HD trial and who continue to participate in the PROOF trial and the open label extension, and also to all the site investigators and coordinators and all the site staff and everybody else involved in this really significant undertaking to try to find a therapy that will help people with Huntington's disease. So we included people who were 25 years or older, men or women. They had to have CAG trinucleotide repeat expansion of greater than or equal to 36, and had to have a clinical diagnosis of Huntington's disease. That's what the diagnostic confidence level, or the DCL of 4 means. It means that people had clinical signs of Huntington's disease leading to a diagnosis of clinical Huntington's disease in this trial. All had to have adult onset Huntington's disease, had to have a total functional capacity of greater than or equal to 7. I think we have a slide later that shows you the total functional capacity. This is a scale that goes from 0 to 13, 13 being normal functioning. We were required that people in the trial have at least a total functional capacity of 7. There's also a scale on the Unified Huntington's Disease Rating Scale, UHDRS, called the Independence Scale, and we require that people have a score of 90% or less on that independence scale. TMS stands for Total Motor Score. That's a scale also that's part of the Unified Huntington's Disease Rating Scale, and we required a score of TMS of greater than or equal to 20. We'll also show you something about that scale a little bit later to give you a sense of the scope of that scale. We allowed people to be on stable doses of medication, of psychoactive medications, antipsychotic medications, antidepressants, chorea medications, such as tetrabenazine or deutetrabenazine, and other psychotropic medications. And we'll talk a little bit more about that. We had a number of exclusion criteria that were really largely based on some issues related to that were raised about potential safety issues from past trials that I'm not going to spend a lot of time talking about actually for today. The primary outcome measure for the trial. So in these large trials that are looking to try to prove efficacy of a drug, we have to pick a primary outcome measure ahead of time. And since in this trial, we're interested in having an impact on function, we chose a measure called the total functional capacity, which measures people's ability to function in daily life. And the primary outcome measure was the change from the beginning of the study, the baseline visit, to week 65 in the total functional capacity. We had several key secondary endpoints that also looked at the change from baseline to week 65 in something called the Composite Unified Huntington's Disease Rating Scale. We'll show you in a moment what that is. It's a composite of different aspects of the UHDRS, including the total functional capacity, total motor score, thinking and memory tests called symbol digit modality, and Stroop word reading, SWR. We also pre-specified ahead of time some of the analyses to include only people who are not taking neuroleptics or not taking neuroleptics or anti-chorea medications, and we'll explain to you why we pre-specified that. We could go to the next slide. So just to give you a few definitions, primary endpoints are typically efficacy measures that address the main research question. The main research question here was, does this drug alter the progression of functional decline in Huntington's disease? And so we chose the primary endpoint to be total functional capacity. Secondary endpoints are chosen to support the claim of efficacy, and so if you have a functional outcome measure, you want to look at measures of motor function and measure of cognitive function and other measures that will help to support the functional primary outcome measure. And so we can look to go to the next slide for additional definitions. We also have the difference between pre-specified versus post hoc analyses, and this is really critical in a clinical trial. Clinical trials measure a lot of things. There's lots and lots of data that are collected in clinical trials. And so, just by chance, there could be things that are positive and things that are negative. So to kind of limit that risk, we have to pre-specify which measures we're interested in. We say ahead of time, these are the things that we think are important. And those things carry more weight because there's much less bias involved in things that you pre-specify. You say, we're interested in looking at patients who are not on neuroleptics, and we say that ahead of time, we're going to do that as an outcome measure, then we're not cherry picking what we're looking at. We're looking at something that we said ahead of time we're interested in. And so that's what we mean by pre-specified analyses. Post hoc analyses can be valuable. That's when you go through the data and you look for things that you didn't necessarily expect or didn't necessarily predict you would be of value to help support the main findings of the study. And they can be of value and can lead to can be useful in further studies, but they tend to be a little less, carry a little less weight than the pre-specified analyses. Next slide.
So I'll take over from here again. So why did we pre-specify the analysis excluding leptics and chorea medication, as Andy just alluded to? So actually, we have data from previous trials that largely informed the design of the PROOF-HD trial. So the PRIDE-HD trial, which many of you, I'm sure, will remember, was a similar sized trial with about 500 people and multiple doses that we tested at that time, where we learned one thing: 45 milligram was the best dose to take forward. That's why we used it in this trial. And actually, we saw when we looked at the data of the PRIDE-HD study that indeed pridopidine had a stronger effect when excluding neuroleptic medications. So if we move to the next slide, you can see on the total functional capacity scale, this global functional scale that was introduced earlier and which is our primary endpoint, or was the primary endpoint in the study. We actually saw that at the endpoint of the trial, we did see a benefit. On the left side, you see here in the medicated people and everybody, including medications. And on the right side, the bar you see is much higher effect. It's in the positive direction, a much higher preservance of function in patients that didn't take neuroleptics and choreic medication. In PRIDE-HD, to note, we had about 34% of patients that were taking neuroleptics, and pridopidine showed these effects. So we'll show in a few minutes how that looked like in PROOF-HD, because we actually had a much higher number of patients taking it in the PROOF study. So in PRIDE, similar to many other studies in the past years, we had the opportunity to use a quantitative objective measure of motor assessment that was initially developed in the TRACK-HD study that many of you will remember, the big biomarker study we did in the Huntington field a couple of years ago. We developed markers that basically translate the clinical scale, the UHDRS, the total motor score that was alluded to already, where when you go to the clinics, you have to do this, pronation, supination, tapping, you have to do finger tapping. It translates it from a clinical subjective assessment of the investigator, which is very rough, 0, 1, 2, 3, 4, very rough categories, to a quantitative tool. If you go to the next slide, so if we use this technology and have a standardized objective assessment of looking at, for instance, pronation, supination, tapping, a very important fine motor thing for everyday life, including like finger movements, we saw in the PRIDE study that you had a benefit actually in people that are just pointed out here. The upper line is the people on pridopidine, and the lower line is placebo. On Q motor measures, we always see that people on the placebo group get worse. So there is disease progression. It's very good. We don't have placebo responses, and you see a clear treatment effect here at 26 weeks, and it's even getting a little better maybe at the 1 year time point. So over 1 year, a very good treatment effect. And now I just said to you, we wanted to look at the effect of the neuroleptics and chorea medication. So if you exclude neuroleptics, you have a stronger effect even here on the objective measure. So the upper line is excluding neuroleptics. The lower line is the whole group treated with 45 milligram pridopidine. And you see that quantitatively, objectively measured, there's just no bias on this. You can actually see that neuroleptics change the outcome on the motor phenotype for that sake. So actually, because of this in PROOF-HD, we pre-specified the analysis of results with and without neuroleptics and chorea medication. We still wanted to assess it because many of you are on those drugs, and we wanted to give access to pridopidine also to the people that are medicated by these or with these drugs. That was the rationale behind it, actually. So yeah, I mean, as I said earlier, basically in this study, the people with neuroleptics and chorea medication, that's the most important message, the lower lines. We see that about 60% of the people are on either neuroleptics or chorea medication. So that was a much bigger group. I said earlier it was 20, 30, 40% in the PRIDE study. We actually had a bigger group on these medications in the PROOF-HD study, and we'll look at the results in a few seconds. Andy, I think you wanted to take that.
Yeah, sure. Yeah, and I'll quickly show you the safety data, which was very, very encouraging. So in clinical trials, we don't talk about side effects. We talk about adverse effects. And we talk about treatment emergent adverse effects. These are adverse events that occur, not effects, adverse events. Because we don't know whether we're blind. We don't know whether people are on active drug or on placebo. So we can't assign effect. So we talk about adverse events, AEs. We say something is treatment emergent if it occurred during the phase of the trial when people were on study drug. So rather than in the screening period or after the trials, when people are taking study drug. And so that's what we call those treatment emergent adverse events. We rate the adverse events according to whether we think they're serious, what are called serious adverse events, or SAEs. And we rate them according to whether we think they might be related to the study drug. Of course, we don't know whether on placebo or on active study drug. We find out after the trial is done. In this case, in the case of the PROOF trial, in the top line, you can see that the treatment emergent adverse events were equally distributed among the pridopidine and the placebo, actually slightly higher in the placebo group compared to the pridopidine group. Related treatment emergent adverse events also very much matched between the pridopidine group and the placebo group. Serious SAEs, maybe slightly more in the pridopidine group, but if you look at serious SAEs that were rated as related, only one event occurred in the trial, and that happened to be in the placebo group, actually. There were 2 deaths in the trial out of 250 patients in pridopidine. Both were in the pridopidine group. So 2 of the 250 patients in that group passed away. One of them had a cardiac arrest a year after stopping medication. So we really didn't think that could be related to the medication. And the other was due to an accident that was rated as not being related to study participation. We'll skip that last line. There were no EKG changes of any concern. And here you'll see some of the more common adverse events that occurred. There's a temptation to use the word side effects, but adverse events that occurred. And you can see that they're basically matched between pridopidine and placebo, and really nothing stands out as being of concern about the study drug. You can go to the next slide. So should I keep going, Ralf, with the primary endpoint, or?
You can do. I'll take the cue order.
Okay, yeah, so we can go on to the primary endpoint, which I'll remind you is the total functional capacity changed from baseline to 65 weeks, including all subjects. In the left panel here, you'll see that there was no apparent effect of pridopidine on the primary outcome measure. At the end of 65 weeks, the placebo group, which is blue, looks pretty much superimposed on the pridopidine group. No difference between them. On the right panel here, if you look, is what happens if you look at people who are not on neuroleptics or anti-chorea medications, and just look at that group. And so here you can start to see a little bit of separation, and it looks like the group on the drug, the purple line, pridopidine, looks like it stays pretty flat up to about a year, 52 weeks. Whereas the placebo group looks like it declines up to a year. These were not statistically significant, but that does look like it's in the right direction, at least. And then we'll go to the next slide. This just shows a different way of analyzing the data, more or less shows the same thing. And we can go to the next slide.
Yeah, so now I'll take over again from Andy to introduce the results of these quantitative objective measures from the PROOF-HD study. You remember I just showed you the results of these quantitative tools from PRIDE-HD. Yeah, just go to the next slide, please. We'll dig right into the data. So even if you look at the whole population, this now is the whole population of the study, including everybody on medication, whatever you take. You can, I think, clearly see here visually that there is, first of all, again, a decline in the placebo group as expected. We don't have any beneficial changes here, which we wouldn't expect. And we know that this doesn't happen on the Q-motor. And then we have treatment effects. There is a significant change actually at the 26-week time point. It wasn't pre-specified as a primary endpoint, but nevertheless, I think it's very interesting to see. It's important and good to see that these measures have a very consistent performance during the trial, so there isn't much variability. And we clearly see that there is something going on. That's substantiated with the next slide, when you then actually take again out the neuroleptics and chorea medication. If you do that, if you look at the quantitative motor Q-motor tool assessments, this endpoint, we see actually significant changes at the major visits. At 65 is the primary endpoint and 26 weeks. And there is a very strong trend you see here at 52 weeks again. So I think this is a key message for me to convey, to say, well, we have, I think, a scientifically fairly clear proof for pridopidine to convey a beneficial effect on the motor domain in the brain. And that corroborates the findings of the PRIDE-HD study, if you remember what we talked about earlier. So actually, we've seen this in 2 trials now, and we've seen it on the same dose. And if you go to the next slide, please, just to corroborate that, many of you may remember that we do this, as I mentioned it earlier, finger tapping as well. So that was pronation, supination tapping before. This is finger tapping. It shows just the same thing. So actually, in this trial, if you take out the neuroleptics and chorea medication, all of the Q-motor measures that we implied, the core measures, show a benefit. So I think we've learned with the use of pridopidine from past trials that there were placebo responses of unexpected size, particularly in the PRIDE-HD study as well. And here we can see that if we use objective data like imaging in other studies, here we have the Q-motor, we do see a treatment effect. And the question for us, I think, is how does that how does that translate to patients? Do patients profit? What patients profit from it? And we had actually interactions with regulatory agencies encouraging us to look at these quantitative tools because they are objective data. And I think it's very encouraging to see that we have these effects. And I think, Astrid, the way you named this seminar, you can see now and maybe understand from the patient side, all of you participating here, that yes, there were some negative results where we didn't see a benefit, but also we clearly see if you take out neuroleptics and chorea medication, there seems to be something here which we would love to have in Huntington's disease. And I don't think we have ever seen any drug improving fine motor control, which is something beyond and maybe more important than changing involuntary movements, to what many of my patients tell me. So a last thing to mention here, Andy just mentioned that the CUHDRS had these effects of medication. The CUHDRS is a composite of very important function in Huntington's disease, function, motor scale, as I just mentioned, but also cognitive scales. You all know that cognition is important in Huntington's disease. We go to the next slide. It may be interesting to mention that for the first time ever, in a huge clinical trial like this, we were able to show here that with this quantitative Q-motor data, you get a correlation to the CUHDRS when you look at the changes over time in the study. So those people that change more, that have more benefit on the Q-motor, also have more benefit on the CUHDRS, which links the Q-motor also to a very important clinical scale in Huntington's disease, and maybe another indication for a potential benefit here for at least a group of patients. Okay, we continue. Andy, I think that was your part.
Sure. Yeah, I can go to the next slide. So Ralf just showed this composite UHDRS or CUHDRS that combines the total functional capacity, the total motor score, and the 2 cognitive measures, the Stroop word reading and the symbol digit modalities test. And if you look at the composite UHDRS on the left panel in all patients, kind of similar to the total functional capacity, there's no statistically significant difference between the groups. But if you start, again, look at the subgroup, just like with Q-motor and with TFC, but even more potently than TFC, If you look at people not taking neuroleptics and not taking anti-chorea meds, all of a sudden, the composite UHDRS looks statistically significantly better up till a year, actually, and there looks to be a trend even through 65 weeks. And so this seems to be a very consistent finding that in patients not taking neuroleptics or anti-chorea meds, all of these measures seem to show a benefit over at least up to a year. And we can go to the next slide. And just to show you this for the Stroop word reading, which is this kind of validated cognitive test that's been used extensively in Huntington's disease. You can go to the next slide. Same thing, actually. So if you look at all patients on the left panel, there are trends there for sure. It looks promising, but not statistically significant. You look at people who are not on neuroleptics or chorea meds in the right panel, all of a sudden it's statistically significant up to a year and looks promising even out to 65 weeks. So very much consistent with Q motor, with TFC, with composite UHDRS. We see the same pattern of findings. So we can go to the next slide.
So I think this was all the data we wanted to share with you today. I hope it was not too much. I hope it was easy to follow, but I think we really wanted to share with you right away, as soon as possible, what the scientific output from this study is. It's a huge project, and I think I admit that. I think it was disappointing for everyone on the team that the primary endpoint didn't straightforward show a benefit of pridopidine in this trial. But, and that's the big part, I think, the pre-specified analysis that we had, as I think we tried to explain to you here today, we showed you, we had thought about before, excluding neuroleptics and chorea medications, we have really seen nominal significant effects on multiple measures, as we just showed to you. On the cUHDRS, as Andy just showed, on the Q motor, which I mentioned was also, showing the benefit in the Pride HD study, bridging to it, on cognition, which is important. So, I mean, these are all features, fine motor improvements, cognitive improvements that we really would like to have available in treating patients, because many of the drugs we currently use actually have detrimental effects on such features. So with the positive trends observed across all Q motor measurements, actually in the study, which we have hardly ever had before, I think with this placebo-independent measure, which gives us a really good credibility of data, there is a clear scientific basis for showing that pridopidine has an effect on the brain and that it has a positive effect. Additional analysis will be ongoing to see what subgroup may profit from it, if this merits further efforts, or whether there is an opportunity to bring pridopidine to some people at this point, for sure. And I think that's important for us to be encouraged to pursue this way further. Pridopidine was very safe and well tolerated across all the trials that were done so far of many hundred people treated. So that's the situation from the data, and I think Michael will now summarize the next strategies and the primary learnings, preliminary.
Thank you, Ralf. Thank you, Andy. Just to say, I think what was quite remarkable for me, just looking at this, was that some of these clinical outcomes weren't just kept static and at baseline, actually showed improvement. So there's improvement in delaying progression of disease. There was motor function that was improved, cognition was improved, and clearly cUHDRS has been accepted and shown to be the most sensitive measure of disease progression. And all the way through to 65 weeks, while not significant at every level, it showed improvement on treatment compared to placebo. And Q motor actually showed independent measures and correlations with other measures, and was seen in all patients, including patients on chorea and neuroleptic medications. Important to say, this is a replication, certainly for Q motor, of what we saw in Pride. So there's confirmatory evidence. And we are now in the open label. And I just want to share a little bit about the open label. The open label is continuing for all participants. It provides continuous access to pridopidine. It's important to note that the pridopidine, certainly we've shown, provides in some patients an overall positive benefit, and it is completely safe. There is no safety risk and very well tolerated. We had a very low dropout rate. And certainly patients who stay in the OLE may continue to derive this benefit. And it's important for us to learn this. And by staying in the study, those people will continue to contribute key data, which will provide information on the long-term efficacy and safety, which will be needed in an effort to talk to others and to get the support of the community. For those who've been on placebo, this is like a crossover, because now they're going to go onto pridopidine, and we will see whether the benefit is seen when they switch from placebo to pridopidine. Important to know that after the OLE, there are no limitations. You will be able to participate in other studies, but it's most important that people stay in the OLE in an effort to derive additional benefit. Also, just to say, there are many studies that have failed primary, but then with open label as well as additional findings have been approved by regulators. For example, just this week, tofersen for ALS failed its primary, and based on the OLE as well as a biomarker was able to get approval just a few days ago. So we're looking, the OLE provides additional information, and we'd be most encouraging of people to stay in this drug, which certainly for some may derive benefit. We're also considering ways to make the OLE less burdensome as we go through this at this particular time. Now, I want to end off by thanking everybody. I want to thank all the participants, and not just the participants, their families. Participating in a trial places huge burden on a family, but people have been amazing. We're all in this together, inextricably bound together, and we need each other. And a community is defined by people who come together to meet profound difficulties. And I would say everybody here has done that. The sites, the investigators, the Huntington Study Group that played such a key role in making the study as efficient as well, together with partners, TFS, CTC, and the European Huntington Disease Network. And of course, my colleagues at Prilenia, who have believed in this based on the data all along, continue to work as hard as they can. But it's not just this group that I'm so grateful to. It's all the lay organizations that have played such a role and worked with us. You know, from the European Huntington Association to HDSA, the Huntington Disease Association, associations in different countries, from Holland to Italy, to Germany, to Scotland, to Spain, and the Huntington Society of Canada, of course, Help for HD, and importantly, HDYO, who are still so desperate for approaches to treatment. So this has been a community effort coming together in ways that are really quite profound. And as you can see, with these findings, we're really exploring this, going to learn more, and then make the appropriate decisions in the best interests of the community we serve. So thank you. And now I hope we have some time for questions.
We do. So thank you so much. I clearly sense some enthusiasm here and engagement, and it tells me that this is definitely not the end. So Philippa, there are some questions and comments in the chat.
Yes, a very busy chat indeed. So I will try to state the questions by the order in which they appeared. So the first question was made by Deb D'Angelo, who asked, can people HD positive get pridopidine via exceptional access program? And if so, how do they go about it?
No, that's a great question. We are, at the moment, the drug is only available as part of an open label to those people who were in the study. There is expanded access in some sites where the drug was available and used, and that expanded access program is not fully utilized, but people need to go back to the sites where the investigators were in an effort to get potentially be part of expanded access. So open label will continue. Eventually, open label will transition into a broader expanded access. But at the moment, the only way, there's some limits for expanded access for people who weren't in the trial, and that should be going through the sites, hopefully a site close to you, where if you want to be part of the expanded access, that still may be possible. Also,
That's one comment to this. This is, however, not a regular pathway, I think. So it's a very exceptional pathway to be able to go to this.
Yeah.
And I think this may also be dependent a bit, I guess, on what we see on further analysis and how this whole program moves. I think, please understand, everyone, we do need to take a little bit of time now to do further analysis and to have a strategy on how to move forward.
Yeah.
We have a second question by Herwig Lange. Isn't predopidine protective for glial cells in the brain too? And also, Herwig suggests that FDA and EMA have to learn that the total functional capacity scale probably is not a good marker for disease progression in the early phase of HD. Can anyone comment on that?
Well, I'll comment. Firstly, nice to see you, Herwig, and so appreciate the long-standing history you have in this illness and your commitment to this community, which is very inspiring. Just to answer, yes, the sigma-1 is expressed in glia and also may be protective for glial cells, but I would say not as well demonstrated as for neurons. And you're quite right on the question of the marker for progression. In Europe, the EMA does accept the cUHDRS as a key measure. In the United States, the FDA isn't quite there. They prefer TFC. But I suspect with so much new changes in the regulators, with changes in some of the people and more regulatory flexibility that we're now seeing in the US, certainly cUHDRS is a recognized endpoint, and we'll have to see how this emerges in further discussions with them.
Casey Fox asked a lot of questions. I think some of them were already answered, namely the ones related to the open label extension and your plans for the open label extension. But there is here one that I don't think it was answered. So is the number of participants excluding neuroleptic powered such as that results would be accepted as significant by the regulatory bodies? What if you would exclude neuroleptics and Korean medicines? Is the number of participants statistically significant still?
Yes. So there were about 100 in each, plus minus, in each group. And of course, this generated significance. Important to note, Q-motor showed significance in everybody. Everybody, whether you're on whatever meds you're on, Q-motor actually showed benefit. When you look at some of the other features where some of the meds can impair cognition, when you took patients off that, these reached significance for Stroop, for cUHDRS, and for Q-motor, which actually showed even better results. So yes, the numbers are there for, and they do reach statistical significance.
So how many participants were on both neuroleptics and chorea medication? And those that were on chorea medication, were they mostly on tetrabenazine or tetrabenazine?
Well, in the treated group, 40%, 60% of patients were on neuroleptics and chorea meds with both. In the placebo group, it was 55%. So, but that, because the trial was large enough, one was still having a group that was sufficiently large enough to give you significance. And of course, just to repeat, Q-motor showed significance in everybody, whatever drugs they were taking.
And I would like to make a short comment here, actually, about that, because I think it's important for all of you to understand what we are thinking. And, you know, actually, we've recently experienced that regulatory agencies have approved a drug in another condition based on a marker. It was NFL. It's a protein that you can measure in the blood. Now, this is an indirect evidence for something going on, and we will have NFL data from this study as well. But Q-motor is actually a clinical readout. So we did something to the clinic. There is nothing indirect to conclude from this. We've shown in 2 huge trials that there was a benefit with predopidine on this domain. And again, saying that we haven't had that before, I think we've had regulatory encouraging statements to say that we can use such measures to seek maybe access to patients in certain ways. And I think it's, like, again, lacking treatment options in Huntington's disease. I think it's our duty to look carefully in all the options that we have, and then learn, maybe, specific people profit more or less from it. There were questions in the chat around the stages of Huntington's disease where this works best. And there was and is, I think, a strong interest of the research people in the field, including Prilenia, I'm pretty sure, to look at the efficacy signs of pridopidine, also in a very, very early cohort of gene carriers in Huntington's disease, if possible. I think it would research-wise be very interesting to do that. And indeed, you are right, there is more use of neuroleptics and other medications in more advanced stages of the disease. And by the way, one message here clearly: don't discontinue your medication because of this trial, okay? So this is a research study. We have to look at this very carefully. I think, there may be people that profit from pridopidine, as we've learned here from the data, and that could be people that use this drug in the future. But at this point in time, this is all research, and clearly, clinically, don't discontinue your drugs that your physicians have prescribed to you. That's a message I didn't want to forget to send. And we will get back to you once we have more data on how pridopidine maybe in the future have an avenue to help you improve on your Huntington's disease.
Thank you. Can I ask a hypothetical question?
Yeah.
Given the knowledge that you have now, what would your inclusion criteria look like if you could take time back and start all over again?
Well, when you do a 65-week trial, the FDA provides guidance. Various documents provide guidance that you have to allow the standard of care. So when we're going to a long-term study, more than a year, you have to really allow patients to be on whatever other meds they are, and other people here may want to comment on that. However, if we're doing a short-term study, maybe up to 1 year or even less than 1 year, then it would be easier to do a study that excluded neuroleptics and chorea, just to see a cleaner number, because you could recruit much less numbers. And what you saw in the study, the improvement, it wasn't just baseline. People improved at 26 weeks. So you show an improvement in function. And so we would think a shorter study that goes without some of these complicating meds. And also importantly, even if you had them, now we would include the primary as key without these neuroleptics. That would be our primary endpoint. If we had a cUHDRS without chorea and neuroleptics in this trial, this would be a successful trial. We just didn't appreciate in the trial the number of patients on these meds, which was way greater than the 36% we saw in PRIDE. So these are things, they are always learnings as you go forward. You look at the Alzheimer's trials, it often takes 3, 4, 5 times. This week, we now, with the appropriate design and everything else, Lilly has come out with a drug that really slows progression in AD. ALS has also gone through this. Huntington, sadly, now will have the least number of drugs and no drugs approved for any progression in this disease. And hopefully we can provide some more information that could be helpful. Our commitment is we will remain engaged as long as we can see data that offers hope for patients. And that's all we want. And I'm reminded, I'm a South African, and I'm reminded of what Nelson Mandela used to say, and it was up on my wall as a young boy in South Africa. It said, everything seems impossible until it is done. And so here we are. It all seems impossible, but we hope that one day this will be done. And we're continuing to analyze the data in multiple ways in an effort to reach some conclusion. And then we'll make the next steps. This is very early days. We're a few weeks into this data.
Thank you. I think there are some really important questions for those who have been in the trial or are in the open label.
Yes.
That we need to make sure that we...
One of them, one question that was asked by 2 people is, for those that are in the first 6 months of the open label extension who choose to stay on the drug, will you be giving participants another 6-month supply at their 6-month open label extension visit?
Yes. So Limor, did you want to comment on our open label extension?
Sure. Yes, our current open label extension is planned to go until February. So we do plan to provide that for up to 12 months at this point.
Maybe I make a short comment here, Michael, if you allow. I actually would like to send a message to everyone, because with the data that we have shown to you in the talk here today, you may well understand that it's crucial and still extremely important for us to gain further knowledge in the open label extension study. And we have actually measures, for instance, the Q-motor, you have really seen this today, that objectively measures motor function. And we can actually use this even in an open label design, because if you don't have a placebo effect, you don't need a placebo control necessarily to conclude scientifically if things change. So we will carefully look at the data that the open label extension study generates when a huge number of people were started on predopidin de novo, and compare how they were doing in the beginning and then during the study, and how long effects were there or not. So you help us to look at what features we might pursue further with predopidin. So that's just one sentence to explain why I think it really makes sense to stay in the trial. Beyond that, I mean, I know a couple of people that say, for me, it works and I would like to stay on it. But for research purposes, you do really help us if you stay on the trial.
I just want to add, I see one very important question that we haven't spoken about yet from Tracy Fox, such an important question, which talks to our ALS data too. In ALS, there is also a measure to look at speech that's observer independent, people speaking to a phone, and then it's analyzed centrally. And to our surprise and somewhat delight, really, we saw that in the whole population of ALS, there were profound improvements in speech, both in articulation rate, speaking rate, and also other measures of speech. And these actually showed even greater effect in patients who were what's called fast progressors in ALS. What they tell us, this measure has been used in many studies. This is the most robust studies they've ever seen with any drug. And of course, speech in Huntington disease is also an issue. And so we do want to consider whether, and by the way, how is it moderated? It's moderated by helping tongue movements, the respiration, and also pharyngeal movements. And the question is that something that could be useful in Huntington disease? And that is something we certainly are very interested in, whether this could help with speech and swallowing in HD, which of course in the later phases of the illness is associated with aspiration and sadly early death. So these are things we still are thinking about, but certainly our ALS phase 3 trial is now in planning. And of course, many of these patients do not take neuroleptics. So we saw the result in the total population of fast progressors, and the speech data was seen in absolutely everybody. So very intriguing speech ways. And speech has been, Bernard Landvermeyer and others are starting to look at speech in HD, but it's understudied in HD. And the question of is whether this drug could help speech and swallowing. And we're just contemplating that right now.
And it's yet another quantitative measure that shows an effect of predopidin, right? So if you look at it objectively, it works. Yeah.
It's like Q-motor, but for ALS, it's completely objective, a different set of investigators, and they're very excited by this, and also have now applied to the ALS Biden Act to get access to the drug for expanded access for people who will not be part of a phase 3 trial. So there's a lot of support in the ALS community.
I would like to make a short comment to a comment that Dina De Souza just did in the chat, which I think, Dina, hi, nice to see you here, is very important. She outlines that not every drug works for everyone. And I think that's something that we clinicians know anyway, right? Whatever condition we treat, if it's Parkinson's disease or multiple sclerosis, there's always some people respond to this drug, others respond to that drug. Of course, we'd hope that maybe there are drugs that will help everyone, but that's not true also for medications that treat chorea. Some profit from this, others profit from that drug. some don't want it at all or don't tolerate it. So I think, Pridopidine, if it helps 2/3 of the people, or whatever percentage it is, that would be fantastic to have. And there might be some people that don't really profit from it in the very end. But if it's a safe drug, we can try it and we can learn more. So I think along those lines, in the future, treatment of Huntington's disease will probably be a combination therapy in the end anyway, right? So the more options we have, the better. And I think, it would be great if we would have a few more options available soon. We should certainly not miss opportunities if we have evidence for things to help.
So, thank you.
I-
So we are coming really close. We are
Dina,
coming
could
really
you-
close to the hour. But you are saying a lot about that. You continue to collect more data. Really, we encourage and hope people can stay on in the open label extension to provide those additional long-term data. But what would then, if things turn out that you see these trends that you have used this hour to explain to us, what would then be, is it possible to tell us, share with us, what would then be a potential next step after you have gathered all these data?
So I don't know if Henk, are you on the line here somewhere? Not
Yes,
I
you
am.
would?
Okay, Henk, maybe you just wanted to share a little bit, but some of the questions was, what would you do with this data? And in the face of missing a primary, maybe how the regulators might view this, and just talking about the new climate with the regulators.
So I think that there are a few points to
Just to
keep in mind.
introduce, Henk is the head of regulatory concerns.
Thank you, Michael. Henk Schuring, Chief Regulatory Officer, Prilenia. There are multiple things here. We live in a world where we have a regulatory environment where there are high unmet needs, and when authorities are willing to consider what they call regulatory flexibility. You have seen that recently in ALS. Another example of diseases where this has been used is Duchenne disease. If you, for example, look in Europe, you will see Etalurin is approved on this type of thinking of what I would call totality of data. So you can miss a primary endpoint, but if your secondaries and other endpoints are supportive, you could still make your case and can get approvals. Is that easy? No. Do we need to go through all the data? Absolutely. But I think one way to look at this, if you have scientifically sound evidence, there is always room to have discussions and make your case and talk to regulators. But it will be important for us to go through all the data and really understand what happened in the study.
And I would just add to that, thank you, Henk, the open label data becomes very important to show the long-term effects, the persistence of effects. So I want to encourage people to stay on the open label at least till, for the time that it's there, because the longer we have data and enough people staying on all their current meds, the stronger the data will be, and we'll learn more and contribute to what could be an information that could be crucial going forward.
Yeah, maybe I can add one point to that, Michael, because patients that may have been originally on placebo and in the open label extension on treatment, we may be able to show a difference in what we call the slope of progression, which will be important additional information in the totality of evidence concept.
Okay. That was a good end, I think. So thank you so much. I think we are here at the hour, and I know we didn't pick up on all your comments and questions, and some of them were also quite, I don't know, for me, scientifically oriented. So sorry for that. But anyway, we were able to answer quite a lot. And again, thank you to the presenters and to all of you for sharing this, and at this point in time, so early, really. We will be here to follow you and support and learn from this in whatever capacity we can.
And
so
I
think we end here.
Yeah, well, thank you all, and thanks everybody. And just to know, our activities reflect our hopes to try and bring something to patients that could have some benefit. We're not giving up on it. Our choices reflect our hopes and not our fears. These are our hopes that we can do something for this community, and we're continuing to work to see what might be possible. So thank you all very much.
I have this little guy here. and he holds up hope. So that's where we end. I don't know if you can see it.
Thank you
Thank
very
you so
much.
much.
Thank you,
Take care,
everybody.
everybody.
Thank you
We will
very
keep you
much.
updated.
Bye-bye. Take
Bye.
care, everyone.